Today's video is mistakes with exponents. This is what I found is the most prolific mistake. So this is what I see a lot. I see students saying, well, I'll just do this. And then they get this answer. They get x squared plus 4. And I'm asking you, is that correct? So let's see what it says. It says that it's like saying 5 squared, and 5 squared means 5 times 5. So this would have to mean x plus 2 times x plus 2. And when we distributed the 2 in, we got this answer. And let's see when we get this one. We're going to expand this. Everybody wants to say FOIL this. We're going to use FOIL to expand it, but we're going to expand this. And we're going to do x times x is x squared. X times 2 is 2x. 2 times x is also 2x, so 2 more x's. And then lastly, we get this. We get 2 times 2 is 4. And we can say with some certainty that it's equal to x squared plus 4x plus 4. And then my question is, are these two equations the same? And they're not. So I want to remind you, what I want to remind all of us is that exponents are not distributable. Not distributable. Distributable. Mutable. Over addition. Over addition. And so many people do this that it's really worth knowing. So just to keep going with that, let's just really quickly answer this question. So we have x plus 3 squared. Is it the same as x squared plus 3 squared, otherwise known as x squared plus 9? No. I'm begging you. It's honestly one of the biggest mistakes I see. The other mistake I see sometimes is this. Somebody will have like ab squared, and then they'll say, well, that's the same as ab squared. Now these are two totally different things. The quantity ab squared is actually a squared b squared. If you see somebody and they write something like a b squared, then that's what they mean. This a is not squared, it's to the first power. The b is the thing that's squared. So the next question goes to this. So if this part is not true, then can you distribute exponents over multiplication? Are you allowed to do this? And the answer is yes. The answer is yes. Let me show you a little bit of proof here. Take 6 squared if you don't mind. 6 squared is 36, isn't it? So I'm going to take my 6 squared and I'm going to say that 2 times 3, this is a multiplication sign, 2 times 3 squared is equal to 36, right? So what we're going to do now is test this. We know that we cannot distribute exponents over addition, but can we distribute them over multiplication? And I think if you look at it, this would be 2 squared, so we'd have 2 squared here, and then we have 3 squared. 3 squared equals 36, question mark. Well, 2 squared is 4. This multiplication sign we haven't used yet, so here it is. 3 squared is 9, and 4 times 9 is in fact 36. So exponents are distributable over multiplication. All right, last thing I want to show you. This is really, really important. Get this. This is a huge mistake. So we have something like 2 to the 3rd power plus 2 to the 5th power. And we'll get, can I make it in a way that you can actually test it? 2 to the 2nd, 2 to the 3rd. And they'll say, okay, that's 2 to the 5th. Question is that true? First off, let me not screw around with this. No. It's not true, but let me prove it to you here, if you don't mind. 2 squared is 4. 2 to the 3rd power is 8. 2 to the 5th power is 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4 times 2. 4 times 4 is 16. 16 times 2 is 32. So 4 plus 8 equals 32, question mark? 12 equals 32, question mark? No. So we're going to have to agree on this. No. So what can we do here? Nothing. Do nothing. do nothing here. So somebody is going to write a comment and say, well, if you had x squared plus x squared, that would certainly be what? Well, we have one x squared here, we have another x squared here, so how many x squareds do we have? Then we have two x squareds. So you can add them, but you can't multiply them. This is not 2x to the fourth or x to the fourth, thing like that, because the rules that we talk about in with exponents have to do with multiplication and division, not with addition and subtraction. So please keep these things in mind. This will be really, really helpful. Should be. Hope so, if you ask me.